Okay. A lot of people actually did really well in this fence question. I guess you just knew what to expect with it, which is good. And we've done ones like this before. So let's just fill out all the variables that we can, mess with here, and then we're gonna switch out one of the variables, just like we've been doing with these optimization questions. Oh, we got this barn over here. There you go, barn. We're building a fence along it, and she plans on building the pen, against the barn, right? So the total area of 3 pens has to be 3,600 square feet. What dimensions will minimize how much fence we need? So what you should have done is label these all as like x's or whatever variable you want. You could also label the whole big thing as one variable. That's fine too. It all works out the same. Okay, and let's call that y there. So you're going to see y and y. Now we don't need a y here because that's going to be on the barn, so we don't actually have to put a fence there. So the amount of fence that we're going to need total is we're going to need 3 of those y's, and we're going to need an x here, x here, x here, and then we're going to need 3 more up top. So we're going to need 6 x's total. And if this had to be cost, like how much it costs or something, then we'd multiply by whatever the cost of each side was. But anyway, we want to minimize the amount of fencing, which means we want to derive this fence equation, but we can't do it with this. It's too many variables right now, y and x. We're going to use the fact that the total area has to be 3,600. Well, that means the total area of this thing is just the length, which is 3x times the width, which is y. So we know that 3x times y has to be 3,600. And that tells us now we can solve for either x or y. I'm going to solve for y only because up here I see y has to get multiplied by 3 and x has to get multiplied by 6. And I'd rather just multiply by a smaller number. So I'm going to solve for y. And it turns out that when you divide by 3x on both sides, y has to be 1,200 divided by x. So in order for the area of this thing to be 3,600 square feet, y has to be 1,200 divided by x. So that means my fence equation is actually 3 times 1,200 over x plus 6x, which means the fence equation is 3,600 over x plus 6x. And I want to know what the minimum value of this thing's going to be. So we're going to derive it. We're not going to do the common denominator here. Remember I told you if you want to derive something, you want to leave the things separate if you can. You get a common denominator when you're trying to solve an equation. So the derivative of f with respect to x is negative 3,600 over x squared plus 6. And if that's confusing for you, all I'm doing there, I'm deriving 3,600 over x like this, 3,600 x to the negative 1. That's what that is. When you derive it, you multiply by negative 1, negative 3,600 x to the negative 2, okay, which just puts it down the bottom, which is why it turned out to that. And we want to know, where's this thing going to be 0? Okay, because those are our critical values. We want to know where it's 0, where it's undefined. So we're going to get a common denominator, and that's going to be x squared. So I got to multiply this 6 by x squared over x squared. And that's going to give me this equation. We need that to be 0 or undefined. And so you see x being 0 makes it undefined. But x being 0 doesn't make any sense anyway, because that means we would have 0 width of this thing. So x can't really be 0, but that's just like a stopping point for us. So 0 is the lowest value on our sign chart, I guess. And then we set the numerator equal to 0, which means 3,600 would have to equal 6x squared. You're going to divide that by 6, which is going to give you, oh my god, 600, good god. And then you take the square root. X is the square root of 600, which happens to be 10 root 6, and that's going to be feet. Okay, now we're going to make a number line for this df over dx because we want to make sure, remember 0's on there, we want to make sure that this is actually a minimum. So we have 10 root 6 here. Okay, I don't know what root 6 is, but I know 10 times root 6 has got to be, I don't know, like 20 something, 30 something. Right? Root 4 is 2, that'd be 20 something. Yeah, root 9 is 30. Oh, 20 something. Okay, man. All right. Gotta be 25, I don't know, 24, something like that. But to plug in a number less than it, I'm just going to plug in like 1. If you plug 1 into this derivative, you're going to get back a negative number. You're going to get negative 3,600 plus 6 is negative. So there's negative here, which means my amount of fence is decreasing as x increases from 0 to 10 root 6. Okay? So the bigger I make x on this interval, the smaller the amount of fence is, until I get to 10 root 6. If I plug in a number after 10 root 6, like 50, you're going to see that this is positive, which means after 10 root 6, if you make x any bigger, the amount of fence starts to increase. So the least amount of fence we're ever going to need, decrease to increase, is right at 10 root 6. And the question just says, what's the dimensions for this? So, since we want to know that, I'm going to erase this just right up here. The dimensions are x has to be 10 root 6 feet. And if you did, if you did this whole side with something, like if you called that whole side something instead of calling each one, then you would have got 30 root 6. Okay? But writing x equals 10 root 6 is fine as long as you labeled your picture and show me what x is. And then y we're going to find by plugging that back into here. So if you plug 10 root 6 into here, you're going to get 1200 over 10 root 6, which is 120. I'll write down here, which is 120 over root 6, which is 120 root 6 over 6 if you rationalize it, which is 20 root 6, because the 6 and the 120 cancel out. So y has to be 20 root 6 feet. And if we use those dimensions, that's the least amount of fence she's going to need to capture 3,600 square feet.